Hi all. See this is a problem of limit, and also we'll take it as in a different ways, right? So let's go ahead and understand the problem first. So let's take that limit as p, okay? So what is the limit here? So the limit p is actually limit n tends to infinity 1 bar n plus 1, n plus 2 dot dot to 3n divided by n to the power 2n, and that's whole to the power 1 by n. That's it. So let's go ahead. So that's implies limit n tends to infinity n plus 1, n plus 2, and how can we get n plus 3n? So that means n plus 2n divided by n to the power 2n, and that's it, whole to the power 1 by n. So you can easily understand that in that product we are having 2n times, right? 2n terms, right? 1, 2, 3 is like that. We have 2n terms, right? Now to find that, we just take n common from everywhere. So that's imply limit n tends to infinity. N common from the first one, we'll get it as 1 by 1 plus n. We'll get 1 common again, so we'll get it as 1 plus 2 to 2 by n, and so on. So if I go ahead, we can write 1 plus 2n divided by n, and that's it, divided by n to the power 2n. Now see, everywhere I take n common, right? From first, second, third. So how many times we n common? We take n common 2 times, right? Or 2n times. So therefore, we can easily write this is n to the power 2n, and hence that 2n terms get cancelled, right? So therefore, my limit can be easily written as limit n tends to infinity 1 plus 1 by n. It's a product of 1 plus 2 by n, and so on. It ends with 1 plus 2n divided by n, and that's it. Now, obviously, you see that for product, the calculating limits and everything become little difficult. So we'll take logarithm, that natural logarithm on both sides. So if I take the natural logarithm, that means ln p is equal to, now see that if I apply natural logarithm here, right, obviously that using power law, that 1 by n came outside and log is applied here, right? And we know that log a, b, c can be written as log a plus log b plus log c, right? So therefore we can say that the given limit can be easily converted to as limit n tends to infinity 1 by n summation of 1 plus r by n, and here we can find that obviously I miss that log here, so add its r goes from 1 to 2n. Now see, r is 1 here, so we'll get the first term. I'll get 2n here, we get the last term. So that's why r is limit from 1 to 2n, right? And wherever we get this problem in this form, we already learned that how, or maybe you learned that how to convert a summation, right, in a integrations form, right? So wherever you see 1 by n, this term, only 1 by is present, there we just write it as dx dy or anything, and wherever we have r by n term, we need to replace it by x, some variable, right? So therefore, this limit can be converted as ln p integration of log of 1 plus x dx, and limit, it is 0, here 2n, that's why we'll write 2. If it is 3n, we'll write 0 to 3. If it is a 5n, 0 to 5. So that's it, okay? So now we are going to find out this limit, right? Now see that this integration need to be performed using integration by parts, right? So let's go ahead and find this integration using integration by parts. Let's go ahead. So I'll do that first without the limit, that easy for us. So log 1 plus x dx that's definitely equal to log 1 plus x will be kept aside, and d dx integration of dx, that gives you x, with a minus sign integration of d dx of 1 plus x, that log x, that gives you 1 plus x, integration of x, that gives you x, and dx. Now this second integration now can be performed as x log 1 plus x. The second integration, we just write it as x plus 1 minus 1 divided by x plus 1 dx. That's imply that x ln 1 plus x, sorry, integration of dx minus integration of dx by x plus 1. That finally gives you x log x plus 1 minus x minus log of x plus 1. That's it. So this is the final integration. Now obviously we need to find ln p by substituting this limit, right? Let's go ahead. So therefore we will find that ln p is equal to, let's go ahead, 0, we just substitute 2. So therefore we get ln 3, 2 ln 3 minus 2 minus ln 3. And if I for 0, every one gets 0, because 0, 0 and log 1 is 0. So let's go ahead. So therefore it will gives you, sorry, this is having a plus sign. I made mistake, just check that. So this is 3 ln 3 minus 2, and that's it. So that's the answer for this problem. But see that here we don't see any problem or anything answer matched with that, right? So therefore we can see that is there any way, right? So obviously we see that in this particular case, right, 3 log 3 minus 2 is the correct answer. But here there is some tricks are there. Let's go ahead and check that as well. See that here 3 ln 3 and 2, if I go ahead, we can write it as ln 3 cube minus log of e square. Because e is the base, so e square we can write. So what happened? It gives you 27, 3, 9 and 27. So therefore it can be written as log of 27 by e square, right? And hence we can see that my required value of p is equal to 27 by e square. And see that sometime, right, sometime we made that mistake. What I forcefully did it here, okay? What? See that here log p is written, right? But we always missed that case when time of exam, and that's why this option is present in your case, that 3 log 3 minus 2, right? Because whenever we do any MCQ type problems, we generally do all the calculation in rough work. So then we miss that we are actually calculating log of p, we are actually calculating ln of p, but we are required to find out p. So what is the exact value of p? The p is 27 by e square, and that's why option B is the correct option here, and that's it. Okay, so that's the problem where we find out the limit using integration approach. That's it. Hope you understood the problem. Thank you.